We now move on to looking at some problem style questions where obviously the little triangle is not given. Now that you've perfected finding sides and angles in a triangle, obviously the appropriate thing to do when you get a problem question is to try and draw or identify a little right angle triangle. So, as is always the case with any written worded question, it's important to read it many times and understand what the question's about. So I'll read through it once, however, I'm sure you're going to need to read through it several times, and you will read through the questions that you'll come across in the exercise, possibly 2, 3, even more times. So this is about a tent pole. Now it doesn't matter that we can't draw a tent, but what we're trying to do is identify a right angle triangle. So it doesn't matter that our diagram doesn't look like a tent. It needs to have, their focus is going to be to establish a right angle triangle, because you could see from the previous examples, once you've got a right angle triangle, you've got the steps for finding either the side or an angle in that triangle. So we're looking to identify a right angle triangle, put the information on, and ultimately decide, are we finding a side or are we finding an angle? So our tent pole, that will do for a tent pole, is 14 metres. It's supported by a rope pegged to the ground. So here's the ground and here's our rope. It's pegged to the ground. What is the length of the rope? Well, I think that's going to be the hypotenuse side. Our pole is at 90 degrees to the ground. Let's call that R for the rope. What is the length of the rope if it is inclined at 53 degrees? Even if you didn't know what the word inclined means, the fact that it says 53 degrees tells you it's the angle. So it's inclined to the horizontal. So the rope, this is horizontal, and the angle between the two, 53, sits in here. So you can see we've identified a right angle triangle. And we've got to find the length of the rope correct to 1 decimal place. We've got all the information on there. We could start our steps. Step 1 is to identify the sides with respect to the angle. So if we look at the angle here, 14 is actually the opposite side, and the unknown side, the rope, is the hypotenuse. We know that the sine of any angle will be opposite and hypotenuse. So we're looking to identify the ratio that has the opposite and hypotenuse, and that's sine. Step 2, substitute. In this example, we know the size of the angle. It's 53. That is a number stored on the calculator. We're finding a side. The opposite side is the 14. The hypotenuse is the rope. From here on, it becomes an algebra question. So we've got an equation. That's a number. That's a number. There's our unknown. If you think about an equation in that format, and please, by all means, if you want to replace that sine 53 with the number on your calculator to convince yourself that you do just have an equation with a number equals a number and a pronumeral, then please do that. But more often than not, you'll see me just leave it as the trig ratio. Thinking algebraically now, to get that R by itself, I want it out of there. I would multiply both sides by R, and that gets it at least out of the denominator. But I can see with R times this number, sine 53, just the number, is equal to 14, that to get the R by itself, that's what I'm solving for. Keep focusing on what you're solving. I would need to divide by sine of 53. So you can see that then that our calculation becomes, to get R is a fraction, 14 divided by sine 53. You can see I've brought up my fraction. Into the top I'm going to put 14, and into the bottom I'm going to put now sine 53. And make sure you close that bracket off, otherwise you'll get an error. And we'll ask for the answer, which is 17.529. And the only reason I didn't put more decimal places is because when I go to write here, the calculator disappears, the on-screen one. So you put in all the decimal places and then round it. It says to 1 decimal place. So we found the length of the side. It would be in meters, the length of the rope. The rope would be measured in meters. And how I know that is because the 14 was measured. The height was measured in meters. Quite a large tent. Quite a large tent. Okay, let's move on, and hopefully this will be revision. Angle of elevation is between the horizontal and rising up. To elevate is to go up. But the angle of depression is between the horizontal and coming down. The things that we know are that the angle of depression and the angle of elevation are equal, and you'll remember this. Hopefully they were called, back in geometry, they were called alternate angles. We'll come across that later in this chapter as well. So another example, example 4, we don't have a diagram, all worded. Our focus is to produce a triangle, a right angle triangle. So again, the words are really important, and you'll see here the angle of elevation. If we don't have an understanding that the angle of elevation is created between the horizontal and going up, then we will struggle to identify a right angle triangle. So the angle of elevation from a boat out to sea to the top of a 350 metre cliff is 13 degrees. So simply we've got out to sea, we've got a cliff, we've got a boat sitting out here, and the angle of elevation to the top of the cliff. Here's the cliff. The angle of elevation from the boat to the top is 13 degrees. And the cliff is 350 metres. The top of the cliff is 350 metres. After the boat travels directly towards the cliff, the angle of elevation from the boat is now 19. So let's say we're coming in, and then we get a second triangle. And this is now 19 degrees. The height of the cliff doesn't change. But it says, how far did the boat travel towards the cliff? So ultimately, that's going to become the distance that we need to identify and give it correct to the nearest metre. Hopefully you can see that X, currently it does not sit in a right angle triangle. So we cannot directly find X. But hopefully what you can see is that from the first original triangle, if we took that entire distance with 13 degrees here and the cliff, and we worked out what, for example, maybe let's call that A, that side. And then we took the second piece of information, where this is now 19, and the cliff, and that distance now is B, then X really is the whole distance of A, so what it was all the way in, which we called A, and we're going to subtract what's left, which is B. So we've got to work on finding A and B, and to do that we will use our trigonometry, and we're finding the side. So here we've got the opposite side, and here we've got the adjacent side. So you can see that we would need the tan of our angle as opposite over adjacent. For the first triangle, its tan 13 is 350 over our adjacent side. So working through finding a side, doing our cross multiplying or multiplying both sides by a, you get a times tan 13 is 350. To get the a by itself, divide by tan 13. Now think about these steps every time you do one of these questions, because that's going to help you with your algebra, solving equations. We're dividing because that's a multiply, and we divide on that side. Here on the calculator you can see I've put in this calculation, 350 over tan 13, and that is equal to 1516. Now, so once we've got our answer for A, the full distance between where the boat initially was and the cliff, we now need to work out how far it is when it is the next observation is taken. Now we've called that B, the angle's 19. The process to get B in this right angle triangle is identical to this process, because this is the opposite and this is the adjacent, which gives us tan. Tan 19 using our opposite over adjacent, cross multiplying both sides by B, and we get this calculation. Now if your calculator is still set up, then we can just use our backwards arrow to get back to this spot. Ask it to delete the 3 and put in a 9, and equals, and we've got 1016. Now we expected that it should be a shorter distance, and it is 1016. You can see then that we know how much is left to go, then how far they've travelled is the difference between the two. So x is the 1516, the bigger distance. This is what's, that shouldn't have a decimal point in it. And doing the subtraction, we get 499.54, etc. It asks for the nearest metre. That 5 means this rounds up to 500. So the boat travelled 500 metres. You should be right now to write your key points, summary of those concepts. Think about the things you're learning here, and then complete exercise 801.